Hi everybody, welcome to my channel, and today I'm going to make the first vlog video, and it will not be about tutorial to explain some technology or some principle, but it's more about sharing ideas. I'm biochemist and I'm working with proteins. I'm trying to purify protein, and currently I try to isolate and purify fluorescent protein, a recombinant protein which has a tag, fluorescent tag. Currently a protein with GFP tag. And my problem is that I'm trying to purify it and check the quality of the protein by gel filtration. So what is gel filtration? Is just a technique able to separate protein from sample. Different protein and separation will be from the mass, from the size of the proteins. So you use a system called FPLC. It's just a pump, and you will make pressure that a liquid that you inject will go through a column and will separate then the protein from the sample. You will have a separation, and to see the protein you have to check the absorbance at 280. And this is the time, correspond to the time of elution. At the beginning, for example, you have baseline, you have nothing, then you have the void, and then you start to come some peaks corresponding to different protein size. Sometimes the resolution between the peak is not good, so you can have something also like this. And my goal is from this sample, complex sample with different proteins. So this is the area of the peak the total area corresponds to the total of the proteins. I would like to see where is my proteins. Maybe it's small peak, or maybe it's a major peak on this elution profile. Maybe it's this peak correspond to GFP protein. And let's but also imagine now you have a sample with RFP. Maybe the RFP is this peak. So RFP protein, and here the GFP protein. So to be able to detect fluorescence, you need, so as I told you, you need a FPLC system that you inject your sample into a column. This column will separate according to the size of the protein. You separate each protein, and then you need a detector, absorbance 280, absorbance detector, that you get finally this plot. And after that you have to add a fluorescence detector to be able to detect, for example, GFP. On this fluorescence detector you have to define excitation wavelengths and emission wavelengths, which will depend of the dye associated to your protein. So you have sophisticated fluorescence detector that you can select exactly which wavelengths and nanometer what you want, and also for the emission. It's really sophisticated optics inside, and use very pure light, which give you all the range, and then you have a selection of the excitation and then emission by different filters. So this is very expensive. It costs around 20,000, and sometimes it's also not adapt to your system. So you need this kind of device, and you need to buy additional software to be able to drive and read your analysis. And this is cost like 20,000, so it's very, very expensive. So my goal is try to develop a cheap system that I will put after my absorbance detector. And this system will not use sophisticated optics, but just simple LED. So first you have to define, I think this is just some idea, you have to define your project. So what you want to read. In my case, I want to read GFP. So I will need to have a right LEDs to excite at the right wavelength the GFP. If I have to use RFP, it will be different. So in my case, I try to get a blue LED. So I order a blue LED. I'm drawing it now. Let's put it like this. You have a blue LED, and this blue LED has some dimension. Why I'm talking about dimension of the LED? It's because later I would like to develop the system like a box that everything will be inside, like the optics, and my idea will be that this system will be driven by Arduino prototyping board. So we have a LED with some dimension. The LED is emitting light. My goal will be to excite a protein which is in my sample after elution, so during the time, so you have flow inside capillaries. Okay, I don't know yet the capillaries, but maybe I will use raw silica capillaries with 1 millimeter out diameter. Okay, 1 millimeter diameter. Okay, where you have this flow of proteins. The goal is to add, so the problem is here I have to focus the excitation light. So the light is coming like this, and my goal is to use a convex lens that will focus exactly in one direction here the light, and then here I will excite, and then of course my sample will emit light with another wavelength, meaning that if I excite with blue, if I have GFP tag, it will excite in green. And now I have to take this signal from my sample. How I can do it? So the best not will be to put the detector just front of the light, but we can put it at 90 degrees. So imagine now we have an axis here, like this. Then I would like to make here my detector. So detector of light, which has a surface like this, and then we will try to get here the light. The problem is you have some contamination light, and to avoid this I would like to put some filter just to take everything, just the emission light, the green, and reject all contamination light. So the green will go through, but the other light come from here will not pass the filter. So this is the idea. So how we can build it? So first step, we can start by the program, but I think the first is try to build optical system. Also how I can place all the stuff. So here we have the LEDs, and as I say, we have to put also the LEDs, and then we have to put the lens. So the lens is, let's put it like this. The diameter of the lens is, so let's put like this, 12.7 millimeter diameter. Then I can talk a little bit also the lens. So the lens, you have to be careful when you buy it. Sometimes they can have a coating, and this coating is very thin, like a nanometer, and they are really sensitive to temperature they can crack, and they're also sensitive to the air pressure, and also you should not touch without glove, so you have to use latex-free glove. And how is a lens? So here you have the TE called edge thickness, and here the dimension is 1.8 millimeter. So I just put some dimension because next step I would like to make the one prototype, not complete, but one prototype of how to dispose all these different components. And it's nice to have because I think I will talk about dimension, and it's important to already know the dimension of your component before to draw something on the computer. It's better to, when you want to design, I think it's better to write everything in 2D before to go directly to 3D dimension. So here we are 1.8. Let's say, to be simple, we made 2 millimeter because I consider that I don't know if you can see, be careful, 2 millimeter. So for the 3D printer, so I'm going to use a 3D printer. I would like to use a PLA material and black that absorb everything. Then it's better than if you have colorate or something else. So black is good for optics. So here we have 2 millimeter and not 1.8 because when you design something in AutoCAD or with software, 3D software, your 3D printer will not exactly make it as it should be. So 1.8 millimeter, it's like the same as, I consider that you have 0.2 variation in dimension. So 1.8 to it's the same. So let's say that this is 2 millimeter, this edge thickness. And for the lens, we have a very important stuff. It's called the back focal length. And this back focal length is start from this part to here. It's where you have the focusing point. And this dimension of the back focal length is around, I think, 11.6 millimeter. So this is important. And this is something also, I would like to design something basic, also to test experimentally when I design my stuff if it's working. So I would like to make a small box where everything is more or less set up in this line before to make the additional part with 90 degrees with the detector. I will just put inline this and see, for example, with positioning a LED plus a lens, and see, for example, with a piece of paper, white paper, I don't know if I can focus on one dot and see if everything is correct before to go forward. Okay, what is also important here, we have a dimension of the lens thickness is 5.1. I consider to be 5 millimeter. As I told you, we simplify. Oh, you cannot see, I'm sorry. 0.2 millimeter. Okay, variation. So it explains that this I changed to 5. And so I would like to design a box. And to make the box, I need to have some dimension. So also here, I would like to put 5 millimeter, not too close. Normally, the LED is not eating, so it should not destroy my lens or make some deformation. But 5 millimeter, I think is good. I'm not sure, but I think is good. Then I want to insert my LEDs inside the cube, and I will use this square here, this angle, to draw a system. So let's make a wall here. This is more or less the flat part of the LEDs, and just before where you have the emission part of the LED. So it's better to put the wall here. The wall, I would like to put 2 millimeter wall. And then we know that this distance here, I told you, is 12.7. Okay? So you need to make a wall exactly 12.7. So here I put it thin just to insert, but not too thin because I don't want that it break, and not too big because I don't want to mask some emitting light. Okay, so here it's 2 millimeter, but I think after we can go bigger and go for 4 millimeter. Let's say 4 millimeter here, thickness. 4 millimeter. Then here we know that the lead, I didn't mention, but the lead here is 1 millimeter thickness here. The diameter is 5.8, so more or less 6, as I said before, that I will make it more simple. Here we have the diameter where I will insert. So this is an important diameter that we should be careful. It's 4.8, but we will put 5 to simplify the system, because anyway the printer is not really precise. You have some difference, as I told you, 0.1, 0.2 you have to consider. Then the position of the LEDs will be here, the lens will be here, so I have to lock it. So I would like to put like a small box of 1 by 1 millimeter like this to block it. And then I will test if everything is fine here with my capillaries. Okay. Here we have also dimension of the LEDs is 9.2. So here we have 9.2, and then we have 1 millimeter here outside. Here we have 2 millimeter of thickness of the wall, so it's 3. 9.2 minus 3, it's 6.2. So this distance here is 6.2. So we know that this should be 2 plus, so 2 plus 6.2 plus 5 plus 5 plus 11.6. And then here I have to think also that I would like maybe to focus my, so here we have emission normally, and then I will put a detector somewhere here. Okay, and I would like maybe to put a second lens to focus of the light from the emission to the detector. So if I'm using also this, I need also to think to make a hole, future hole here, where the diameter will be 12.6. Okay, so it's important. So this is something that we have to think later. But first I would like to design this first part to see, for example, if I make it like this, then I will put a film, a paper, white paper, I don't know, to see if I can focus and everything is fine, to really define if it's 11, you know, it's not exactly, this is theoric, and after when you print it can be some difference. So it's important according to what you start to prototype, the 3D prototyping, then maybe you have some changes. So I would like to make theoric, experimental, go back to theoric, experimental, and then to try to make the best and to have something as I can to be accurate. Okay, and also later when I will dispose the lens inside, I will try to see here if I put something to really lock the lens. But first let's start to make this. So let's go to the computer. So we are now on the computer, so let's start SketchUp. SketchUp is a program to make 3D objects. It's nice, powerful and free.
So we choose millimeter, because from the beginning I'm always talking in millimeter. Remove this. Then I would like to make a prototype, so something really simple. So let's start with a rectangle. I don't know yet the dimension here, but we know already this dimension. It will be, so here let's put, to start, 49 millimeter, and here I would like to put, so we know that the thickness of the wall here will be 4 millimeter. Then we have the diameter of the lens, which is 12.7. We add 0.2 millimeter, so it will be 12.9 to be sure that we can insert the LEDs, and then again 4 millimeter. So 12.9 plus 4 plus 4, it's 20.9. Enter. Wow, it's small. Okay, so now we have this. Okay, let's move a little bit. We can already, so we are going to make, I think the best will be to make a bottom top building to build our object. So here is the base of our object, and then here we'd like to make 4 millimeter thickness also on the bottom part of our device. So here 4, so we put some dot here, and we extrude this until here. Okay, so we have already this bottom part like this. So now I'm going to put some line to define, for example, the wall. Here it's 4 millimeter. Here we have 4 millimeter, again here 4 millimeter wall. Let's put a line, and then here we decide to put it thinner for the reason that I explained before. It is 2 millimeter. Okay, like this. Then okay, so now we have 2 millimeter wall here, 4 millimeter here, and 4 millimeter. The LED will be insert like this. So now I have to define the where is finishing the LED inside the box, the future box. We know that the distance of the LED is 9.2, sorry. 9.2, we have external part, it's 1, and the thickness is 2 millimeter, so it means that from here to here we have 6.2, so 9.2 minus 3, 6.2. Enter. So the LED finish here. We decide to make randomly, I'm not sure, but 5 millimeter distance between the LED and the lens, and the lens we also decide to put 5 millimeter of lens. So the lens is finishing here, here, and here. And here I have to put this small, I will say a small cube, or just to lock the LEDs. So let's draw something. Let's zoom also, it will be better. So 1 millimeter like this, 1 millimeter in this direction, and finally we put 1 millimeter like this. We do the same on the other side, 1 millimeter. So we will see, we will print it and see how it look like and if it's working. And what is important here is to add now this back focal length, which is 11.6. So okay, so it means that my LED will be until here, 5 millimeter distance. Then we have here the edge thickness of 2. Let's put just to have some font. Okay, so the edge thickness of the LED, then we have the curve of the LED until here. Here is the, I will say, the base of the LED, be a flat part, more or less lock by here. And then from here to here, 11.6. Okay, so the capillaries maybe will come from down to up. Okay, and then at 90 degrees from here I need to put my detector. I don't know how I will put it, but let's think that maybe I will add a second lens to focalize. I don't know. So maybe we should also think about this for the dimension. So the length is 12.7, but we say that is 12.9, and 12.9 divided by 2, it's 6.45, and also from here 6.45. Then we have some idea of distance. Okay, I would like not to stop my device directly here, but for maybe we should add a little bit distance, like 3 millimeter. And then don't forget that we have also a thickness of the wall on this side. Okay, so it means that we make it a little bit longer so we can put it until here. Okay, so let's put some line. So the wall will be like this. Okay, let's turn. We'll now adjust. So first I have to select the face like this. Then we adjust this until this dot like this. Perfect. Okay, so now I'm going to extrude down to the top. So let's do it. So we draw it like this. Tack. Yes. So extrude. Oh, sorry. Then I have to select the surface, this surface that I would like to extrude. Okay. Does it change something? No, it's perfect. From this side is good. So I extrude, but until where? Until the same distance. Here we say that is 20.9, so I would like to put the same distance on the top, like from this face it will be a square. Alors, I have to put from here to here 20.9. Okay, so I'm a bit too low. Selection this surface and go to this point. Perfect. Okay, let's start to look something. So imagine we will add here the lens, and now I need to put the LED hole because I want to insert from this side. Okay, so again I need to know the middle, so diagonal like this. So here I should draw a circle, so we know that the diameter, the real diameter of the inner diameter of the LED is 4.8. However, because of the resolution of the printer, let's put 5. So 5, it means that the radius is 2.5. 2.5. Enter. Okay, let's remove this this piece. Okay. Okay, thank you. Why it doesn't? Okay. Okay, now it's good. Okay, so here you see clearly the hole where we will insert from here the LED, and then here we put the lens. So I think we are now quite good. According to the 2D plan that we did, and now we have a 3D object. Looks great. And this 3D object I would like to print and to test. So I will also take maybe not the LED that I order, which are relatively powerful, but we start with basic LED. Anyway, I just need light, so I will put it here. Also, I will measure dimension to see if it's correct, place the lens, and then test it with maybe a piece of paper, or I will see, and to see if it's really 11.6, if it's correct or not. Okay, so let's save it in STL5 and let's go to print it.
So here is the object that we just print now, and as you can see inside we have here the stuff to block our lens. Here we have the hole for the LEDs, but I would like, so it look quite nice, and the resolution is look quite good quality. I would like to check how is accurate. So now here we should have, let's put it properly, we should at 4 we have 4.1, here we have 4, and here we have 4.1, and here 4.1. Okay, on the back 4.1 exactly. So 0.1 it's not so bad, the difference. Okay, here we should have 1 millimeter, we have 1.2, 1.2 also here. You see it's between 0.1 0.2. Concerning the inside, we should have 12.9, but we have 12.7, so this is good because it's exactly the diameter. 12.7, yes, 12.7 in both sides, so it's exactly the diameter of our lens, so it should work. Okay, so now I would like to test my prototype, and to test it I don't want to use my expensive LEDs. I would like to use like a basic LED, 5mm diameter. So the LED is light emitting diode. There is a plus and a minus. You have to be careful. The plus is here, it's called anode, and this is the minus, is the cathode. Usually LEDs work with between 4.5 volt, but the most important thing is the current. So you have to make a limit resistance resistor to limit the current of the LED. The maximal current, usually it's around 20 milliamp. The best when you want to run properly, carefully your LED, you have to run between 9-10 milliamp, and usually people use resistor around 330 ohm. But today, so I'm going to use a power supply with 5 volt, and so let's make some calculation. If I want to push the system, so let's see. If I want to push the system, so we have the Ohm law, which is the voltage equal the resistance multiply by the current. Then if I want to know the resistance, it's so the voltage divided by the current. The voltage is in volt and the current is in amps. Here we would like to put 5 volt, okay, and here I would like to put let's push the system 20 milliamp, so it corresponds to 0.02 amp. So the resistance is 5 divided by 0.02, which is equal to 250 ohm. I don't have 250 ohm. Let's check. No, I have 220 ohm. Okay, so we are going to use this. So let's see now. I have this. Let's take resistance. We have resistance here. I would like to take, be careful, so we say that it's important to check the cathode anode, so make it properly. So I would like, usually we use the black for the minus, for the ground, and the red for the positive. Some shrinkable tube also I would like to use. And let's make some soldering. So let's see, let's cut a little bit this. Okay. You always have to prepare the wiring, the wire. Okay, let's cut a piece of this. So the minus, so I will protect this. Let's put it far, because if it's eating, then you're in the shit. It will collapse. So the positive is the longer one. Let's bend a little bit. And also this is not in the right position. So I don't care, it's really not super important LED. So a third end is always good. I have also to put a little bit soldering stuff here. Yeah, don't eat too much the LED. It's not good. So now we put it together properly. Like this. Yeah. Perfect. I think like this. Then we do the same for this guy. Oh, don't forget to put the sheet. Up. It's not necessary, but it's better, because imagine you bend a little bit, then the plus and minus is touching, just to make it properly. Yes. You know, soldering is not really difficult. The most important part is always to prepare your soldering. That's it. Okay. Okay. So now I have the LED with the wire. Oh, one thing I forgot is to add the resistance. I'm really stupid. I want to... it's not good. Let's remove the resistance. Okay. So it's not easy with the camera close to me. Okay. Then maybe what I could do is this. Take half part of this. That I will put it here. Yes. Now it's better. Where? So I think it's not necessary to add this one, but let's put it. It's just that, you know, if you protect already one, it's okay. But let's do it like this. That's it. So now the resistance, it makes no sense. You don't necessarily to put the resistance on the positive or negative. It just need to be on the circuit. So now let's put 230 degrees. Okay, so now I think I will cut the video and just prepare everything to test the device. So I connect now everything. The LED is connected to my power supply where I can regulate the voltage. So I will increase slowly the voltage just to show how much power we have and from which voltage we start to have some light. So now I am at 2.5, we start to have something. So you see that now I am 3, 4. Let's remove the light. So it's quite nice, huh?
So here I am at 2.5 until 4. Yes, I am at 4, so it's quite strong light, even with cheap small LED. Okay, so now we like to add the lens. So the lens, as I told you, it came in the special box with protection. I'm wearing gloves now to take out this lens, which is here. Up, it's here exactly on the corner. I will take it and I will place on my system. But on the back here. Okay. So now it's in place. Let's increase, and we have now 2.5. So you see we have a ring. The light is really focused compared to what I presented before. Let's shut down. Quite focused. We still have some here dispersion of light, but this is normal. It comes from because it's open system. However, we are really looking for what is going on in the back here. Okay, so I will put a paper, and for this paper, I will just reduce a little bit the light like this. Then we have less perturbation. So I will just put here the paper to see where is my focal back focal lens. So I'm going down, down, down. The ring is a little bit reduced, but it's not really big. You see that you have like a focus ring, but I still have some light. You have two rings, one in the middle which is focused, the other one is not, is like low intensity. It's difficult to see, by eyes is better, we really see better focus compared when you are see it with the camera. And here it's like I am now on the back. So yeah, it's big, large, and now it's focus. Yeah, we see, and here I should be around 1 centimeter. But it's not exactly what I was expected. Honestly, I was really expected something that is really focused on one dot, like maximum 3 micromillimeter, you know. But yes, well, it's like this. Let's put a little bit maybe power. And now I am at 4 volt. Let's go 4 volt. So it's really strong, but it's quite large stuff. Yeah, there is something, but it's not really focused as I was expected. Okay, let's put back the light. We can see that the LED it's working. Huh? The LED is working. Let's remove it from this like this disconnect here. Yeah, it's here. And then just with the normal light, and you see I am around 1 centimeter from the bottom, and it's really focusing. So I don't know why it's not really nice as we can see now. So I just realized something very interesting. When you remove the LEDs and you use the lens as I used before with the normal light, it works. It means that maybe the distance between the LEDs and the lens is not correct and has to be set up. So just to show you what I saw, I put in dark, then put 2.5 volt. Yeah, I'm 2.5 volt. Now I'm taking the LEDs in my hand, and then when you put the LEDs, you see it's difficult to focus, but you have a dot. It's much better than when you are too close. Okay, if you are too close,
like I want to make it 5 mm, then of course if you put a piece of paper, you don't have this nice focus. Okay, even if you are close to one, if you have the lens, the distance between the lens and the paper of 1 centimeter around, and you put too close the lens or front of the lens, then it's not nice focus. You need to be a little bit far from the LED, as you can see here. Okay, so it's something that I will set up now. So now I just put the LEDs on one support with a breadboard to see what is the experimental distance where the LEDs should be set up. So let's put in the dark. So here you can see that I set up the lens with a background which is focus at exactly the distance, the 11.7 millimeter that you have really a dot. And now if you put the source of light too close, you don't have this focus anymore. So it's very important to really define the best distance here of your source of light. So now I will measure it.